Okay, so first I have to identify what this is. You understand that in here, I have to have this number times the function for all of them. The base times the height plus the base times the height. So it's going to be the base times the height, base times height. I'm going to write it here as well. Base multiplied by height. Because it's the sum of all areas, of all rectangles, of course. Base times height. So how do I get the base? The base is denoted by delta x. That's the base of each and every one of them. In our case, it was 2 minus 0 divided by their number, the number of subintervals. We chose 2. That's why this number is 1. But in general, delta x will be the base, and it will be b minus a over n, because now we have n subintervals. And a and b are coming from the interval. So find the exact area under the graph of f of x on the given interval. So the base will be delta x. Now let's see what the height for each subinterval is. Obviously the function. Either the function here, or the function value here, or the function value here. It doesn't matter. It doesn't matter anymore. Why? Because n approaches infinity. Who cares? If I'm using this, or I'm using this, or I'm using this, the number of subintervals goes to infinity. So it's not important. But this depends on the location, however. So at the first subinterval, it was f of 0.5. On the next subinterval, it was f of 1.5. On the first subinterval, it was f of 1. On the second one was f of 2. On the next one will be f of 3, and so on and so forth. So this will change. So this depends on the location, which means it will depend on I. So it will be f of xi, or x sub I. This has a name. It's called Riemann Sum. So in short, the exact area under f of x, and I put in parentheses, f of x must be continuous. Exact area under f of x, which must be continuous on the interval a comma b, is the limit of the Riemann sum. And now let's calculate some Riemann sums. And other expressions. And then we have one other option, which I will explain when we get to find the exact area. This is not the only option, but we're going to look at this option first. Okay, I'm on page 388. We'd like to start with maybe a summation notation, so you see that it's in your book on page 388. I gave you a couple of examples, but let's say problem 13. And we have the sum from I equals 0 to 10 from I squared. We know what this means. So I'll remember this is 10. So again, if you have this calculator, that's fine. Go to summation notation. And of course, we have x, and it starts at 0, and it ends at 10. And it's from I squared, which means x squared. And you press enter, and you get 385. I'm going to write a few elements. So when I is 0, it's 0 squared. When I is 1 squared. And when I is 2 squared, dot, 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 till 10 squared. And again, it was 385. This is an example from your book. Okay, let's look at problem. Yes.
Quick. Okay, so when you got 385, let's say if our calculator does not have that, is there a way we can do it?
Yes, I no longer have a calculator. Yes. You have to go to catalog. I used to have an old calculator. It broke. The screen could not. I was typing anything and it would just be blank. So I had to get rid of it. And then the other one that I had, I spilled water on. So now I'm trying to protect this one. So yes, there is a syntax with second and catalog, and see, it's all sorts of stuff. I'm not sure. I think they all have glitches these days. I'm not sure what's going on. This is brand new calculator. So you have to go to the summation notation. This is a sequence, and I don't remember the exact syntax, but I think it's the sum of a sequence, and you have to write from I'm trying to read.
If you don't know, I can search it up later.
Yeah. So, but this is the sum of the sequence, and it's you have to put the lower limit, which in this case is 0, the upper limit, which is 10, and I think you also have to write x. And you close the parenthesis, and you should be able to get, I'm sorry, I squared first, so x squared. You have to put x squared so the calculator doesn't know which general term I have, and then x, I think. And you should, when you click, so insert this here. So, and you should get 385. But you have to look for the sum of the sequence, and you go to second and catalog, and you should click on S. This may have it. So second alpha S, and it jumps to S. So let me see now if I can find it. Okay, I need the sum first. SUM first. Yeah, it already gives me this. So it's the sum. And then you have to go back to the sequence now. Second alpha and S. Okay, the cipher. Oh, wait a second. I didn't even get the chance to do anything. Okay, sum of the sequence. 0, 10, comma, x squared. And I think it's going to ask us to put x as well. I'm not sure. Yeah, it doesn't like the syntax. 0, 10, yeah, something it doesn't like. So I can look it up for you.
No, it's okay. I'll try to find out later today.
Yes,
if not,
so
then I'll email you.
Yeah, sure. I will try to find it for you. Now
okay.
this is how we determine it, the sum of the sequence. It's the sum, and this is the sequence, and from the lower limit to the upper limit, maybe it's asking, I don't remember if we have to put x squared first. Maybe that's what it is. X squared, comma, 0, comma, 10, comma. It may not need the x. This new calculator may not need x. I'm not sure. No, it doesn't like it.
It's okay. I'll try to find out.
Yeah,
I will.
It up. Yes. So there is a way. There is a way, even with the older calculators.
Thank you.
Thank you. I promise to look it up.
Okay.
Okay. So moving on. So let's find the approximate area. Let's look at 17. And this is on page 388. And we want to find the approximate area under the following graph of f of x, which is 1 over x squared, over the interval 1 comma 7, by computing the area of each rectangle to 4 decimal places and then adding. It doesn't tell us to use the leftmost point, the rightmost point, the midpoint. Okay? So it says, I'm looking to see, they're not telling us how many rectangles, but they show the graph, 1, 2, 3, 4, 5, 6. So they're indirectly telling us that n equals 6. Okay, so let's do that. If we graph the function, you will see that this is the graph, and this is 1, and somewhere here I have 7, and this is the area in question. We want to approximate it. Before I do this, I want to show you that some areas could be negative. So if I have to calculate the area of under this graph, in other words, between the function and the x-axis, between 0 and 10, this will be a positive area, but this will be a negative area, so the answer will be negative. So don't be surprised. Not in this case, because the function is positive. If the function is always positive, I cannot have a negative area. Good. So we are dividing the interval into 6 subintervals, 1, 2, 3, 4, 5, 6, 7. Which one would you like to use? The leftmost point, they're not indicating. We have to decide. It doesn't say. We want to use the midpoint. We want to use the leftmost point. We want to use the rightmost point. Regardless, the area with 6 subintervals, so let's make a decision. Left, right, or mid? Okay, I'm going to use the left. Left with 6 subintervals equals. That will be the width of the interval. So delta x will be 7 minus 1 divided by 6. So that's why 6 over 6 is 1. I will pull it in front. And then in parentheses, because I'm using the leftmost point, I will have f of 1 plus f of 2 plus f of 3 plus f of 4 plus f of 5 and plus f of 6. In other words, this is the sum from I equals 1 through 6, because I have 6 subintervals, from delta x, which is 1, times f of xi. When I is 1, I have f of 1. When I is 2, I have f of 2. When I is 3, I have f of 3, dot, 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 till f6. Since I have to determine these values, I will use the graphing calculator. Let's see. I wish I had that ready for you so you can do it together with me. I didn't think. Okay, so from I equals 1, x equals 1, till 6. And 1 is 1, I don't even have to write it. But xi is 1 over x squared. So I will write this in the following way. So from I equals 1 through 6, from 1 over I squared. I squared. In the calculator, I have to put x. So 1 divided by, I'm not sure whether the calculator needs another set of parentheses, but to be on the safe side, I'm going to put another set of parentheses. X squared, and close the parenthesis. Okay, so when I click enter, I get 1.49 blah, blah, blah. Why did I write 0? Let me see how many decimal, they said 4 decimal places. Okay, so 1.4914. In part B, they're asking us to, this time to use 2, 4, 6, 8, 10, 12.
What function is that?
1 over I squared.
Oh, okay, thank you.
Thank you. So now they want us to repeat with more decimal, with more double the sub intervals, 12. So we didn't need extra parentheses, but sometimes it does. So careful if you have the same calculator. Okay, so with 12 subintervals, do not purchase a calculator just for this. There is no need. I will find the syntax for you. So the sum from I equals 1 through 12 from 1 over I squared is 1.56497. So I'm going to change it to 5 because they want 4 decimal digits. Any questions?
I actually found out how to do the sum equation on the calculator.
You mean the syntax?
Yeah.
Okay, so it's the sum of the sequence, and then?
And it says expression, variable.
Yes, sum of the sequence. So in our case, it would be 1 over x squared. Yes, the variable, yes. So yes, it's the expression is the variable, and then the lower limit, and then the upper limit. Thank you for doing this.
After the upper limit, you have to put the increments.
So, okay, so it wants the increment, so I'm going to put the increment 1. Okay, so that was missing. So let's do that. So second in catalog, in order to jump to sum, use second, alpha, and natural log to jump to, because otherwise there, I don't even know how many options are here. So maybe it's better to jump to T instead of S and go back. So sum, thank you. Sequence, again, thank you for helping me with that. Okay, so we have 1 divided by x squared, and then comma, x, comma, 0, comma, 10, comma, 1, close 2 sets of parentheses, and press enter. So the increment 1 through 10, why did I put 10? So we want to determine this one. So it's still 1 over x squared, that's correct, and then x and 0, and then to 6, and the increment of 1. 1 over 6, yeah, so we should get 1.4. It doesn't like it. Maybe it wants parentheses here. Let me see. Maybe this calculator doesn't work, but maybe your calculator works with this, because I think it's probably a conflict here. Yeah, it won't allow me to do it here, but it should work with yours. Hersh, did it work with your calculator?
I'm